Hello and welcome to another session in mathematics. In this session, we'll be looking at set theory, but before we do that, let us look at the previous lesson. Welcome back. In this lesson, we'll be looking at the definition of terms and symbols of sets. Definition of terms and symbols of set. That will be our major focus, so that we'll be able to understand the terms we use here in sets and the symbols also of sets. Okay, let us start with the definition of set. A set is a collection of well-defined objects, things or numbers with what common characteristics. Okay, a well-defined object, collection of well-defined objects, things or numbers with common characteristics. Mark that. Okay, for instance, we talk of a set of positive even numbers from 1 to 20. Positive or even numbers. We know what even numbers are. We have 2, have 4, 6, 8, 10, and the rest of them. Okay, we can also have a set of pregnant women. Pregnant women. Is that correct? Yeah, that's a set too. Okay, then we have a set of secondary school students. Secondary school students. Okay, now that's a collection of well-defined what objects with what common characteristics. Okay, so we have things we need to note here. In sets, capital letters like A, B, C, D, and the rest of them are used to denote a set. We use it to denote a set, while small letters are used to denote the element or members of a set. We use small letters A, B, C, D, and rest of them to denote the element or members. You can call it elements or members of what a given set. Okay, capital letters for set, small letters for elements. And then in every set, there is a comma separating one element from the other. Okay, if we have a set of 1, 2, 3, 4, now you observe that there is a comma separating each number from the other. Okay, now number 3, we have the next one. When it is impossible to write down all the elements, then we use dots to do what? To identify that, and that dot means what, and so on. If we have a set of 1, 2, 3, and so on. Okay, so we are telling people that the set doesn't just end in 3, that there are other numbers that are not written down in this set. Okay, then we have number 4. Set is enclosed by what? A curly bracket, as seen here. Since we started, I've been using curly bracket instead of the real bracket, so it uses what? A curly bracket of this form. Okay, then the order of arrangement of numbers of sets does not really matter. Okay, you can have a set of 1, 4, 2, 5, 3, but normally if you want to arrange it orderly, it should be 1, 2, 3, 4, and 5. But even if it is arranged in this manner, it doesn't matter. Okay, that's why they said the order of arrangement of numbers of sets does not what matter. It doesn't matter. Okay, then let us quickly look at the elements of a set. I told us that is either you call it elements of a set or you call it what? Members of a set. They said that elements of a set are the members of a set. The members of a set. Okay, and the symbol for is an element of or belongs to is this. We use this italic E. Okay, this means what? Is a member or element of. If we want to say that 2 is an element of set A, we have set A here. If we want to say that 2 is an element of A, then we say 2 right down at E is an element of what? A. This means that 2 is inside what? The set A. Okay, do we understand? Yeah, we want to express that a number is not an element of a given set or does not belong to a given set. Then we now use let's say in this set there is no 6, so we say that 6 is not After writing this, you cancel it. Is not what? An element of what? A. Remember, when we say normally in mathematics, when we say that 2 is equal to let's say x, we cannot as well say that 2 is not equal to x. Is that not correct? So when we want to use the word not equal to, we write equality sign and then cancel it. Same thing applies to finding the elements and numbers that are not elements or members of a given set. When they are members of a given set, then we use this. When they are not, we use this. Okay, let's quickly look at numbers of elements in a set. Numbers of elements in a set. He said the number of a set, let's say set B, is written as what? NB. NB. Now the small letter denotes what? The number of the set B, and this can be called the cardinal number of sets. The cardinal number of what? Set. Let's say for instance we are given P to be equal to the set of odd numbers between 10 to 20. Find what? NP. N means what? Number of what? P. Remember, we are told that P is equal to what? The number, the set of odd numbers. P is equal to the set of what? Odd numbers between 10 and 20. So all we need to do now is then to write down the odd numbers between 10 to 20. So we have 10, 11, 12, 13, 14 till 20. Then in that set, we now pick out what? The odd numbers. And that's how we got this. 11 is an odd number. Odd numbers are those numbers that cannot be divided by 2. Okay? So we have 13, we have 15, we have 17, we have 19. So how many are there? We count 1, 2, 3, 4, 5. Okay? So we are asked to find NP, where N is the number of what? P. So NP is equal to what now? 5. Okay? That's how we got this. Is that correct? Now, we have the equal set. Sets are said to be equal if they contain the same elements. If they contain the same elements. And I want you to note here that the order or arrangement also does not really matter. Okay? Now we have an example. If P is equal to A, B, C, D, and Q is equal to C, A, D, B. Remember, they all have the same element, but the arrangement is not the same. But looking at these two sets, we say that what? P is equal to Q, because you can as well rearrange Q to be of the form A, B, C, D. So the arrangement does not really matter. What matters is what? The members of the set. Okay, so we are looking at the members, not the arrangement. Okay, so we say that P is equal to what? Q. And when two sets are equal, we say that what? They have the same what? Element. When they have the same elements, they are equal. Okay, let's quickly look at empty set or null set. We call it empty set or null set if the set has no what? Element or member. If a set has no element or member, then it is said to be what? Empty set or null set. And we use the symbol this, or we write a curly bracket with no element inside. So we either use this or we use this. Okay, the both of them are correct. And I want you to note that when you have a set containing this or a set containing 0, this is not an empty set. Hope you know, because there's an element 0. 0 is an element, and there we have a 0, a cancelled 0. It's also what? An element. So when you have a set containing these two things, we don't say that they are what? Empty. Okay, because 0 is counted as what? One of the letters or numbers in a set. Okay, so if we have the set of a 5-year-old student in JS1, over there I know you people use grade 6. Just imagine having a 5-year-old boy in grade 6. How possible is that? Is it possible? It's not attainable. So if a 5-year-old boy cannot be in grade 6, therefore we say that the set is equal to what? Is equal to, therefore we say that the set is what? Is 0, or we say that the set is what? Empty. Okay, do we understand? Okay, so we have what we call finite set. Okay, he said a set whose elements can be counted is said to be finite. Once the elements, the numbers or the members of a set can be counted, then we say they are what? They are finite. For instance, we have the set of even numbers from 1 to 10. Even numbers from 1 to 10 includes 2, 4, 6, 8, and 10. Is that correct? So they can be counted. 2, 4, 6, 8, 10. They can be counted. So we say they are what? Finite set. We say the set of state governors in Nigeria. And in Nigeria, we know how many states we have in Nigeria. 36 what? States. Is that correct? So we can easily mention the names of the 36 governors in Nigeria. Okay. Now we have what we call the infinite set. This is the opposite of the finite set. Infinite set is a set whose elements cannot be counted. Okay, they cannot be counted. Just imagine someone telling you to write all the even numbers we have here on earth. How possible is that? Do you even know where to start or where to end? It will be possible for you to be able to list all the what even numbers, or someone telling you to write the names of all the pregnant women in the world. The names of all pregnant women in the world. Oh my God, when will you finish that project? All pregnant women in the world. Okay, that's an infinite set because it will not be achieved or attained. Okay, then we have the disjoint set. Two or more sets are said to be disjoint if they have no element in common. If they have no element in common, then they are disjoint. We have A to be equal to set of 1, 2, 3, 4, and then we have B to be equal to 7, 8, 9, 10. Since there is no intersection, then these two sets are said to be what? Disjoint. Because there is no what? There is no common element, then they are what? Disjoint. They are disjoint, and they are seen in this form. Okay, there's no what? Point of intersection. They don't have anything in common, so they are what? Disjoint. Okay, we have difference of two sets. Difference of two sets. The difference of two sets, A minus B, is a set of elements in A but not in B. Like the elements you can find in this A, but they are not in B. They are called what? The difference of two sets. So you find the numbers that are in A, in set A, that are not in set B. Now, for instance, we are asked to find them A minus B and B minus A in we're asked to find A minus B and B minus A, giving A to be equal to the set of 1, 3, 5, 6, and 8, and then our B to be the set of 2, 5, 7, and 8. So I told us that the difference of two sets means what? The numbers that are in A which are not what? In B. So let us start. 1 is in A, there is no 1 in B, so we write 1. There is 3 in A, there is no 3 in B, we write 3. There is 5 here and there is 5 here, so we omit that. There is 6 here, there is no 6 in B, we write down 6. There is 8 here and there is 8 here, so that means A minus B is equal to 1, 3, and 6. Then we are asked to find them B minus A also. B minus A means the numbers in B that are not what? In A. So we have 2, there is no 2 here, we write down 2. We have 5, there is 5 here, so we omit that. There is 7 here, there is no 7, we write down 7. There is 8 here and there is 8, so we have this to be set of what? 2 and 7. So A minus B is set of 1, 3, 6, and B minus A is set of what? 2 and 7. Okay, having studied the introductory part of sets, please kindly provide the answers to the following question on the screen. Welcome back. We'll stop here for today. Do well to use the lesson note on the platform for better information on the topic we've just discussed, and feel free to drop your questions or comment on the comment section till we meet in our next class. Stay safe and bye.